Why can I not show slides? Got it. Thank you. So this is odd. I'm not able to show slides. I didn't do that, however.
Like that?
Oh,
It was me.
so, so Sophia, you've got, okay, if you want to do that, then please show the chair slides now, and I'll
Yes,
ask
yes.
you to
They
go
are
forward.
showing. They are showing, right?
Nope, they're not.
No, they're not. Because they
No,
showed to
your
me.
face is, or your non-face is showing.
Ah, interesting.
I
But they're
can't
not.
see the slides remotely.
You can see the slides.
Yeah, we can see it remotely, yes.
Ah, I can't see the slides. Okay, that's interesting. Okay. I'm sorry? Yeah, that's fine. That's fine.
I'm going to stop
Oh, I
sharing.
see them over there. You know what? I'm going to
Okay,
move so I'm watching. I can, well, I'll just look over there. Okay. Let's give it one more minute, but then we'll start because we actually have a fairly, not packed agenda, but a very long discussion ready. So, it's so funny. Oh, we are seeing you over there. It's like, I'm the only one who can see Sophia. No, you can see her over here. So, please, well, we'll hit it when we hit the first slide. Why don't we just get going because we have enough introductory slides. So next slide, Sophia, since I can't have a clicker. Okay, so welcome. This is PQUIP Working Group. It is a working group in the IETF. Here's the note well, which you cannot read on the screen, but you already agreed to it when you registered. Thank you for registering. Nothing has changed in the note well, but it is still important. If you're already here at Thursday and you haven't read it or you clicked through early, please go back and read it. It's actually a reasonable thing. Next slide. And then here is something that they're calling the, really note well or note really well. This is about the way that we treat each other. This is the way we talk with each other and such like that. This is PQUIP Working Group does not develop protocols. So the good news on that is we can't fight with each other about like record formats and such. The bad news is many of us can have a stronger opinion without backing it up, and therefore we might want to be more forceful about it. Let's not. Let's remember that everyone here, comes in pretty much the same. Let's treat each other well. If you're feeling you're not being treated appropriately, if there's any harassment going on, there is the IETF ombudsman person, such like that. Let's really do this in a way that is the best thing for the IETF, because this working group really is here to help the IETF, not just ourselves. General agreement? Good. Next slide. So here are the meeting tips, and I've noticed, well, you all can read them, but the first one is the most important. If you're sitting here in the room, the best way to do things is to join Meetico from that little icon over there, the online tool. And that way you're not accidentally going to turn on your in-room speaker and such like that. For the remote participants, welcome. And I see that we have plenty instructions here on how to do that. Really, Meetico is our friend. For those of you who have been coming to the IETF for more than, say, 10 years, you will recognize how much better off we are with these procedures and such, so please do these as indicated. Next slide. So here is a overview of what we're going to do today. This is the brief overview. The full agenda, there's a link there, or you can see it in the data tracker. We're going to start off with current document status. Fortunately, we don't have many presentations on that, but we have some specific things going on. We will very, very briefly discuss previously discussed documents, but we're not doing any presentations on them. We're going to zip over them and instead talk about them much more on the mailing list. We've got a short description of what happened at the hackathon for PQC certificates. Then we have what's going to be the meat of the meeting. We've got 90 minutes, and I think we might spend as much as an hour on this. We might not, don't know, but on things that people have been seeing on the PQUIP mailing list, and for those of you who are following the NIST mailing list, what we've been seeing on the NIST mailing list is a bunch of IETF participants saying, hey, this doesn't work for, this individual thing doesn't work for us and such like that. So, and many people get confused because a lot of the issues are cross-linked. So we've got a presentation on that, and there will be plenty of time for Q&A at the end of that presentation, I believe, if we give it like 60 minutes. And then we have what a few people on the mailing list had asked for a discussion of PQC algorithms across the IETF. Should we be discussing across the IETF issues here in PQUIP? Should it be done in SAG and such like that? We'll have a short discussion on that because there will be more discussion tomorrow in SAG, and there is already discussion on the SAG mailing list for that. And then if there is any time at the end, we'll do an all other business, but I think that that's actually fairly full for 90 minutes. And I don't see anyone jumping up disagreeing. So thank you. Okay, so next slide. Actually, I can't even read that. Hang on a moment. Let me get this up on my screen. I can see Sophia really easily. I can barely see the text.
Maybe there, if I remove my camera.
Nope, that doesn't help. I'm perfectly happy to see your face. You are here. I mean, you're there, but you're here. But I guess this is quantum. Okay, so our current document status. We have been diligently working on 3 documents, over the last few months. These are the documents that are in our charter, and they aren't individually listed in the charter, but this is fulfilling our charter requirement of document things that are worthwhile across the IETF. Paul, are you getting up to disagree with me on that? Or okay, do you want to hop in now? Okay, you just want to stand by a mic. That's fine.
Waiting your third bullet point.
Yeah, that's fine. And we have a presentation for the third bullet point as well. Oh, no, for the third bullet point of the first item. Right, okay. So the first one that we moved through is the terminology document for hybrid schemes. That was submitted to the ISG for publication in September. And I have stuck question mark here, and our AD, Paul Wouters, is going to explain what that means.
Hi, Paul Wouters. So the reason it is stuck is because somewhat of the history of the document, right? There is a large discussion in the working group, progress was made, and then last minute there was a huge amount of words sent to the mailing list about disagreements by a few participants. And the problem is that people more or less said, like, this is either too late on the process, we've already answered this before, we're not going to do it again. And so basically nobody read that last email very well. And it's a huge email. I understand why the working group did this. So then the document moved forward, and then even the document shepherd didn't go and said, like, there was a huge discussion, this happened. So I feel now that now this document has gone to me, that it's now my job to actually go through that email and see what is actually, if there's actually anything in it that we should consider as a working group. So, and that has just delayed me, because now I have to read both a huge document and a huge email that goes with it, plus the previous discussions that happened that the working group considers resolved. So it's just a lot more work for me, and so it took a little bit longer, and so it's not stuck.
Okay.
It's just that there's just some additional work from my end.
Great, thank you. And I thought I had put in the write-up that that everything that wasn't addressed in that long message was that there was no other support for it, so that it was an individual contribution that did not have support. But if I didn't get that clear, or if you want to clarify more on that,
I also got signals that people said I didn't even read the entire email. So I
okay.
feel that I really have
Don't
to go
tell
through
our
it.
AD that, okay? But the flip side of that is some people do send really, really long comments about our drafts to the mailing list. This is how we improve things. You really should read those really, really long emails. You don't have to like them. You can say at the end, didn't really care, but none of what we're talking about here is easy. I mean, if it was easy, we wouldn't have needed a document on hybrids, on terminology for hybrids. It's not easy, so let's give each other the benefit of the doubt and actually read these things. So the second document is hybrid signature spectrums, and I have in here that it's, you know, the
Sorry,
working.
Paul.
Yep.
Sorry, Paul. Can I just jump in on the terminology one? Happy
Okay.
to help with any review. So as one of the authors, I did go through the long email. I tried to make kind of updates where the suggestions were really practical. So happy to kind of work with you on the bits that that I changed and where there was consensus from the group.
Thank you, Michael.
Cool.
Yep. So on hybrid signature spectrums, the working group last call ends today. We got some comments, which is great, and the authors have been good about updating the document. However, I think that there are people who got caught up in, you know, travel to Dublin, preparing for it, such like that. So I'm going to extend the working group last call to Monday. So like something for you to read on the airplane on the way home or such like that. I'm not expecting any additional comments, but in case we can get some, I mean, we would like to move this one forward as well. I think we're pretty good right now, but I'm gonna actually close the working group last call on Monday. We will expect, you know, a final draft. I'll announce it. People can look at the diffs and such like that, but then that will close. Our third document is post-quantum cryptography for engineers. We've got a presentation on that. So Sophia, you can sort of cue that one up. So it's finished working group last call. The authors are making some changes. I made an editorial pass. It was pretty drastic. So it'll be pretty hard to read the diffs, but they're incorporating them, and we have some non-editorial stuff. So come on up and let's go. Tim's going to do it, and Sophia, can you do the slides for that?
Oh boy, this is going to be really fun with these slides over there. All right.
Yeah, you know, we can
Well,
move it over there.
we're going to have camera problems. The camera's right there, so
Got it.
people won't
Okay.
be able to see me if I move.
Right.
I think I can see most of the slide, and this should be relatively fast. The reason we did a presentation is because we did receive a very large number of comments, and oh, that's perfect. Thank you, Sophia.
Bless you, whoever did that.
She figured out the solution to the problem that I couldn't think of. Yeah, so we have just a brief presentation on what we did and getting feedback, because we're really close to done and we're trying to get this across the finish line. And so I want to make sure that our proposed direction for addressing the comments is in line with what all you guys think it should be. Next slide, please. All right, so PQC for engineers, it's explaining why engineers need to be aware of post-quantum cryptography and what to do about it. The goal here is really to rapidly increase the number of engineers who understand this problem and can help us with it. So the potential impact of cryptographically relevant quantum computers you're all familiar with. We've been working on this since IETF 117. Next slide. All right, since the last one, Paul actually already did this for us, and thank you very much for his very significant time commitment on this. As we mentioned, we're mostly just working through comments. Next slide. One of them, the comments had a lot of similarities. One of them was, who is the audience? A lot of people thought that the audience wasn't quite well enough specified, and that the draft suffers from it because it tries to do too many things. And we agree, it's largely around what does the word engineer mean? IETF protocol designers are here in this room and can talk to other people. That is a very useful audience for this document. It is not the primary audience. We think the primary audience is people like non-IETF developers who have to use PQC algorithms in new systems, system maintainers that need to update their systems to be quantum safe, but don't really understand what that means at a technical level. And maybe things like network operators and things like that who also could benefit from a deep technical understanding of these issues. There's some others like people who manage HSMs or auditors and things like that. Those are people who perhaps are a little bit further down the food chain, and maybe the draft's trying to be all things to all people, and maybe we should just restrict it a bit. So we're thinking the question mark is there because the authors think that maybe the sweet spot is sort of this, for the primary audience, is this people in this area. I see there's one in the queue. If that's a question about this, that was the idea. So welcome to hear the feedback on this slide.
Johanna? Oh, you took yourself out of the queue. Okay.
Okay.
Thank you.
No problem. But yeah, as far as the audience question, if you're fine with our idea that the primary goal here is helping technical engineers outside of the US rapidly get familiar with what's going on inside the IETF, that's sort of our proposed audience. Deidre?
Hi, I agree on making targeted recommendations and sort of explanations of what these things mean for engineers, non-cryptographers. I do not think that necessarily elides a lot of, we use these things because there's a security definition, a security property that usually has a proof behind it and assumptions and stuff like that. Hiding too much of that information from the engineers who don't need to know about it. I'm not saying like inline a proof and explain gate. I'm not saying that. I'm saying that we think these things are safe because of assumptions and proofs and cryptographic notions. So that chems rely on this NCCA thing, which is slightly different than some of the things you used for Diffie-Hellman. Just enough to put a basis on it, because even if we are targeting engineers, protocol operators, hardware operators, they are, by upgrading from classical to post-quantum cryptography, doing cryptography whether they think they are or not. So yes, targeting specific recommendations to an audience like this, I definitely agree with, but also including enough cryptographic rationale and basis because it kind of floats out into the world and it has to have a basis in what we actually think these things are secure and why, which is formal mathematics and cryptography.
Very well said. I wholeheartedly agree with you. It's a very technical document and it will remain so.
And if you are finding parts of the document which don't say that, please do send in, doesn't even have to be full text, but to say this bit of how proofs work would go here reasonably well. Yeah.
Yep, absolutely.
So even though we're done with working group last call, there's going to be another, round again. So please do that. And please don't forget, after working group last call, there's a full IETF last call, and working group members are welcome to say things during IETF last call that they didn't before. But let's get that in if we can do it earlier, especially because during IETF last call, people from the TLS working group and others will be looking at it, and they're familiar with what you're asking. So thanks.
Mike?
Mike Ellsworth, Interest. Two thoughts. First one is I sort of half-heartedly disagree with Deirdre. I'll attempt to not get speared explaining why. Deirdre, I believe, is in category 0, like yourself,
Sure.
Category 0, which is not on this slide, which is you are a cryptographer.
Yeah.
But you were these people only a few years ago. Okay, cool. But I think you are a extremely smart person who spends a lot of time educating the category 1 people, and that's excellent and valuable work, but I think not what this document is trying to do.
So actually, I'm going to stop you there. If she wants to suggest where things can go in, why don't we then look at the specific things and places she wants and then choose or not? There's plenty of category 0 people around, but they sometimes have interacted with even the 5s and 6s.
Okay, so then my second point, yeah, absolutely. I mean, specific suggestions welcome for sure. My second point is addressing a comment that I think we didn't, from Ori, that I think didn't make it in the deck, but is sort of entangled with this slide, which is, should we be using RFC, what is it, 2119? Like, should we be using normative musts and shoulds? Or is this an informational document and should absolutely refrain from using normative language? Like, is this
Absolutely.
document supposed to be making recommendations or
Nope.
like supposed to not be making
No,
recommendations?
it is supposed to not be making recommendations.
Yep.
Kathleen Moriarty. So this is an offer. If you'd like to get some of those other people represented for reviews, I may be able to help with that. And sitting listening to the discussion, I was just thinking of my own students when they're looking and learning about stuff with TLS. They like Nick Sullivan's very, very detailed draft, if you remember, or I'm sorry, blog. I prefer looking at RFC, what is it, 8996? Is that the right one? Is that TLS? Whatever TLS 1.3 is, I prefer that directly. So I think getting the right people to review it that actually check the boxes. And that's how you're going to get your audience.
So actual reader reviews.
Yeah. So I can help with some of those because I have graduate level students that are working and some are, meeting those categories.
Right.
I think we would love to accept your offer. We've been begging for years for reviews, and more reviews are better. Absolutely.
Right.
Yep. And if anyone else has connections, what I find helpful is just tell them they'll get acknowledged in a document. And because they don't realize that when you say, can you review this document?
So yeah, and those reviews can happen at any time. Like even though we have a working group last call, then an AD review, all the way through IETF last call. Don't wait for IETF last call if you've got people who can be reviewing.
Joe?
Yeah, this is Joe Soloway. I was just going to echo support for Deirdre's comment that being a little bit more on the technical side, I think is advantageous here because I think where we're going to see gaps in kind of documentation is towards that side, more towards the IETF protocol developer, maybe not somebody who's actually developing IETF protocols, but they're making, similar decisions in their applications where they actually may be doing things that they need to understand those properties. And if we leave that information out, then I'd be concerned that we're putting them at a disadvantage.
Well, absolutely. And those people fall directly in number 3. There are a lot of non-IETF protocol designers, and they need to have the same level of expertise that the IETF level protocol designers have. Yep. Paul.
Paul, speaking as an individual, I do think there should be a bit of a limit though. Like when you're implementing as an engineer, I think it would be good if you get advice from this document and maybe leave a comment in your code that says, this must be constant time implementation because of blah. I don't think I need to understand blah. In fact, I just hope that the whatever reference is good enough for me to copy some code.
Yes, absolutely. If this is a great reference for people to defend their opinions and point to other smart people when they're confronted with people who have opinions that are slightly less than smart, yes, that's useful.
Okay.
All right.
Next slide.
Next slide. All right, current state of the document. One of the comments we got was, I think this document is really useful, but really, really needs editorial work. And we agree. That's what actually I'm going to be working on for the next couple of weeks. So definitely agree with that. Next slide. This is another one that came up in lots of comments. PQC and quantum safe. They mean different things. MLDSA, MLChem, SLHDSA. Even if you don't like the name for them, the term for those things is post-quantum algorithms and post-quantum cryptography. It's a class of technology. There's a security property that a lot of people call quantum safe. Some other people use other terms for it. But you can take those algorithms as a building block to give your system this security property, if it's a security property you need. And so this was discussed extensively on the NIST PQC list. They declined to change the term from PQC. So we're using their term for the algorithms, and it's in the definition, and that's why it's PQC for engineers. So this one keeps coming up, and we just wanted to address it so everybody knows why we're using the terms the way that we're using them.
And just as a note, it's also addressed in the document so that if people want to go, oh, I don't like the term, it's actually explained in there as well.
Yep. And if that explanation needs to be improved, please provide comments about why it doesn't work for you. Next slide. The other one is, and this is one that I'm going to have to do a lot of thinking about. A lot of people pointed out we use various terms like break and things like that. Q-day is also a term that's wandering around for when quantum computers actually start breaking things and causing pragmatic security attacks that actually compromise the security of the system. Academic cryptographers use the word break very differently. If I have a 110-bit attack for a key search against AES is broken, despite the fact that it's also not broken. So I think we'll use a different word and explain it differently because that term is kind of loaded and means different things to different people. So I'll try to figure out a way to express practical changes that cause us to actually have to do emergency patches to systems and things like that. Mike?
Mike Ainsworth, sort of speaking as an author here. Almost put this on the slide, thought it was too cheeky to be on the slide, but I encountered this really great YouTube video recently that said the way that researchers, especially cryptographic researchers, use the word break is very different than lay people. Like, I have a garden shed in my backyard, is his example. And when a cryptographer says, I have a break for the lock, what they mean is, I invented a new lockpick, which is at least as good as the current best lockpick. Whereas the layman means, like, you're in my garden shed and my stuff is gone. And I think those are two very different uses of the word break that we probably need to think carefully about how to frame.
And that can be also done on the list because there are people who are lock pickers and there are people who have garden sheds on the list. So I think that we can actually, get that.
Absolutely.
Yeah.
Yeah. If you want to tell me what the right answer is and what I should say and save me a ton of work, please do.
Please.
Next slide. Algorithm names, we're going with what the emerging NIST consensus is, which is the names are the NIST names. We only use Kyber and dilithium when we're talking about historical stuff. It's a different algorithm. Kyber and MLChem do not interoperate, for example. So that's why the names are the way they are. We're getting a lot of comments about, why aren't you calling it Kyber? Everybody calls it Kyber. We're not calling it Kyber because it's not Kyber. Next slide. And then just thank you for your feedback. We'll be giving you guys an updated draft soon. So thank you for your time.
Thank you. And more discussion on the list, clearly.
Absolutely.
Great. Thanks, Tim. Sophia, back to the chair slides. And we're on slide some number. Next one. So these are two drafts that have previously been discussed and have not been adopted by the working group yet. We're not going to discuss them today at all. We've got some things that are better for interactive. These will be discussed on the list, but there was the migration use case document and also the state and backup management document. The second document is somewhat driven by the NIST documents, but regardless, nothing on those today. We will bring them up on the list. We will see if the working group wants to adopt them. That you may not. It may be that we're done. Depends on some of the discussion we'll have at the very end, which is about our charter. Okay, next. So we've got a brief presentation on post-quantum cryptography in certificates. You aren't winning anything, I assure you, other than having to listen to a bad echo of your voice.
Which slides are now?
Oh, this is the PQC and certificates slides.
Okay.
Hello, everybody. So I made it down here. So yeah, I get to talk to you about the hackathon. That was last weekend. Sophie will bring up the slides in a second. So if you can go to the next slide. So yeah, it was November 2nd and 3rd. So obviously, so this is our 7th one that we've done this. We got together at London in 2022 and said, let's make these PQ certificate things and see if they'll work. It has expanded from there. So we also testing CMS artifacts and other things, chems and CMP and things like that. So, I mean, the purpose is if you're doing something with the PQ, adding it into one of the, X509 drafts, there's many of them being written there. There's a bunch of them listed there. Come join us and yeah, we can see if we can get the things working with the PQ algorithms. Also, the other important thing is that we give feedback to the authors. So some of the drafts, we've, implemented, I think, ML DSA certificates, and, there's been feedback back and forth and all that kind of thing. So that's, I think, a useful part of this project as well. So I'm just going to go over what happened this time. So if you can go to the next slide. Yeah, so one of the things that changed was we have to test with the certificates, we have a zip file and you upload them and you put your certificates in there, self-signed CA certificates, basically. So we updated the format of that file because we used to support PEM encoding, we used to support DIR encoding, and the naming of it was just OI numbers, and it was a bit confusing for people when they actually looked at what was in those zip files. So now we're only using DIR encoding because PEM, despite being around for 20 years, people would still get it wrong. So just removing it is not going to be an issue, right? So anyways, we updated that format to what we call the V4 certificates. Sorry, it's not a certificate, it's just a V4 zip file format that we use for artifact testing. In the last hackathon, so back in the summer, we added automated GitHub actions, which was really cool. So now if you submit one of these zip files, it would run against libOQS and Bouncy Castle. So that was updated as well to support the new V4 format. But also a new PQUIP, so a new basic, I think it's in this later slide, the name of the company. But anyway, they are adding an automated GitHub action as well. And I think this is the old version of slides because I fixed, anyway, it's GitHub. It's not GitHub, sorry about that. Anyway, so the other cool thing is that
sometimes it feels like GitHub.
Yeah, the other cool thing is the ACVP test. So we had someone start that. That has not been completed yet, but we're hoping sometime in the next few months and to get the ACVP automation working as well, because then when people upload that, then you'll be able to have libOQS, Bouncy Castle, ACVP, and then PQUIP. And if other people want to add automation, they can do that as well. So if you can go to the next slide too. So the automation part is really exciting. So one thing that was discovered during testing, so we're testing CMS artifacts. So like I said, we have expanded the scope a little bit. So testing CMS chem, the private keys, we hadn't really used those before because in certificates, we were just using public key, right? Public key and signature. Well, in chem, you actually use the private key, and we found, oh, some people were using the 32-byte C and some were using the long form. That obviously caused an incompatibility, which we would expect to happen. The other thing is there was some ASN1 wrapping inside. So one of the persons used ASN1 wrapping inside the internal octet string, and the other one didn't. So basically that just shows you we definitely need a standard format. And the cool thing is that draft consensus and lots of discussion at LAMPS happened, and other groups as well, that everyone seems to be aligned on the 32-byte seed. So that'll be the way going forward. But that was just, the hackathon showed that definitely if we don't do this, it's going to cause an incompatibility. So I think that was a great output just to see that in action. And yeah, also the other thing, someone is working on automated GitHub actions for CMS artifacts. So the cool thing is that, this keeps going. People are adding these automations, and it's just going to make it more valuable. So go to the next slide. Just a couple other things to mention. Yeah, so composite chem is being worked on by a number of parties. I know there's been some interop with that. Composite signatures, the 03 draft actually was fully interop between two parties, Bouncy Castle and CryptoSense, I think, and which is really cool because that only came out 2 weeks ago. There was also some testing of the hash MLDSA, so I know those aren't supposed to be used in certificates, but for testing of the hash MLDSA, so the message format with the hash, we just allowed that just for testing, right? So anyway, so that's listed in the tables as well. And also, Alex Raelian was showed me a really cool ASN1 querying tool for RFC structures and Pi ASN1 modules. So that sounds, if you're interested in that, you can talk to him about that. But essentially, he's been working on a CMP automated test suite that will be part of the output of this project as well. And part of that, he wrote this ASN1 querying tool, so it looks really useful. So that's basically what got done. And I just wanted to show you quickly kind of what, so if you go to the GitHub page, you'll see the outputs. But if you go to the next slide, it should show you, yeah, so this is the automated compatibility matrix. Now you'll see these kind of like half filled in things. That means passing some verifiers. The reason at the moment is because you probably most of you know libOQS has not, they have a pull request for the final MLDSA, but it's not there yet. And because we had automated tooling against LibOQS, obviously that's not going to work. So you can see in the right hand, it's showing that OQS is not working. So anyway, once that pull request is done and we update that automation to the latest, those should turn green, which we want because green is good. And then the next page just shows, if you go to the next slide, please. It will show, yeah, so there's much more green on this one. So this is the manual one, so people can download a zip file artifact from all the different providers, manually run it against their code, and then basically upload back the results. And then this table is automatically generated based on those results. So you can see there was a lot of testing going on. And this isn't even the full list. I'd have to do like 5 pages or something to show it all to you. So if you go to the next slide, be my last slide or close to the end. Yeah, so essentially the GitHub link there is at the bottom. So if you go there, you can actually see the full list. You can see everyone in detail and who interrupted with who and all that. So that's great. We continue to meet and have monthly meetings. Tuesday, December 3rd is our next one. So if anyone wants to join, you're welcome. Just let me know. We just meet on a Teams meeting, so I can send that to you. Maybe we've done virtual interim hackathons as well, which has been fun. So we take a Saturday and do that. I actually find I get more work done on those because when I'm in person, we do a lot of talking. And you can see the team members. We've just had a ton of people over the last couple of years. So thank you to all you. Some of you are in this room that have participated. And yeah, obviously with all the new algorithms and things coming, we're going to need to keep testing these things. So that's the summary. Any questions?
Thanks, John. Okay, next up we have Mike. And Sophia, you can just go straight to Mike's slides, the NIST slides. Yep, thank you. We have 53 minutes. Mike, I'll ask you to do no more than 40 minutes so that we have time for questions at the end. Certainly expecting stuff to possibly run over and be on the list, but you can see that's the 52 full. So
You want me to stop at 40?
I would say stop at 40 or 42 or
Okay,
something like that, just so we have a bit of time
long.
at the end for Paul to talk about the last thing with SAG and also our charter. Go for it.
Yeah, all right. So this is an intimidatingly large room, considering that I was asked to give an intimidatingly pointy presentation. You're all far back, so I won't get hit by rocks, and that's reassuring. So I wrote this deck over this week. I've had input from a bunch of people. In input, I'm not claiming these people agree to the content. I'm just saying thank you all these people for reviewing the slides and helping me hone the messaging here. So the point of this, what I've been asked to come up and talk about is we have FIPS 204, 203, and 204. They were published earlier this year. We've now had a few months to play with them, to write software against them, to really study their wording in intricate detail. And now the community has emerged a few sort of sticky issues relating to some pretty nitpicky stuff. And I think NIST, there shouldn't be anything in here that's surprising for NIST, and I think there probably shouldn't be anything in this deck that's surprising for the experts. But the point of this deck is to disseminate what I think now the core group of experts has converged on, in, like even within the last week, and disseminate that back out to the wider community. So some of these points look sticky, and a bunch of us have gotten trapped in thinking they're sticky, and then we realize actually they're not as sticky as we thought. So hopefully I can just sort of clear up some of the miscommunication around these points. And there are a couple that really are sticky, and we need NIST help with them. Okay, next slide, please. Yeah, that's what this says. So the purpose of this presentation, we're just trying to summarize the current state of the ongoing discussions. Not trying to do anything new. I'm just trying to sort of collect together many megabytes of email thread into a more compact slide deck. This is all my personal understanding. I may not understand things perfectly. I may understand things differently tomorrow. Don't quote me on anything that's in here. Any single thing might be wrong. This is very fresh. This is very evolving. The PQC forum mailing lists, the IETF PQUIP mailing lists, these mailing lists fly a million miles a minute. It all changes fairly quickly. the authors of the various IETF composite things, had a meeting with NIST on October 17th to discuss specifically the chem combiners that we have in composites and X-Wings and other places, and how this is going to work under the not yet published NIST SP 800-227. And that was a super amazingly productive meeting. And I think we all came away from that with a better, clearer understanding of where the problems are. And we're doing a follow-up meeting, hopefully in the next few weeks. So like, I just want to make clear, this presentation is very today. And the content in this presentation may no longer be accurate next week, but I still think it's valuable to do it. Also, shout out to Deirdre's blog. Certainly for topic 1, I just basically pulled it verbatim out of Deirdre's blog, which is like, did I lose my mic? No, I'm good. Which is like a better blog than my slides. So go read Deirdre's blog. It's excellent. Next, please. Okay, 5 topics. I'm just going to skip this and let's just do them. Next slide, please.
Yeah, sure.
Topic number
Next slide. Yep.
1. Lattice private keys, seeds versus expanded. This is obvious, you say. Why is this on a slide, you say? Why is this sticky, you say? We're just doing seeds. Next slide, please. Okay. So we like seeds. Seeds are good. Seeds sort of look like this. There's this thing called MLDSA keygen internal, which takes a squiggle, which I believe is the Greek letter chi, maybe? It's 32 bytes. MLChem takes 2 seeds, a D and a Z, because I'm not American, and so that is 2 32-byte seeds for a total of 64 bytes of seed. And some people have cleverly pointed out, we'll get to this later, but MLChem only needs 256 bits of entropy, or only claims 256 bits of entropy. Why do I need 512 bits of seed? And that's a good observation that I will address in a future slide. So, okay, seeds are better. So you then run this keygen internal, you get a fully expanded matrix, private key matrixy thing, which is much larger. Can we just store the seed? The keygen is actually fairly efficient. We don't particularly mind expanding the seed often as we need it. You get some performance benefit from caching the expanded seed, but like it's not catastrophic. So like, can we just store the small thing if we want to store the small thing? And in particular, if I want to carry this over a wire in a P12 or a JWK or something, can I just carry the really small thing instead of carrying the really big thing? And the answer is yes, we want to do that. That's great. There's also a security benefit to doing this. Normally, when you store less data, you have less security, but this is sort of intuitively backwards. If you store less data, you actually get more security. And there's this great paper, the Unbindable Chemie-Schmidt attacks from Sophie Schmig, Dr. Schmig, which is excellent and sort of goes through some of the things you can do when, particularly you can sort of, there's some exploitable, I'm not going to attempt to explain that paper, but there's some exploitable conditions where if the attacker can muck with the private key, then you can force the public key and the private key to be mismatched. And then you can force some exploitable conditions where you decapsulate with a public key and a private key that don't match, and then things can get a bit weird. If the honest decryptor is rederiving their key from seed, then you cannot force a mismatch between public and private, because you just derived them fresh on the spot. So there's no possible mismatch. And so a whole like category of attacks goes away. And this is even more true if you derive both D and Z together. So if you only store a single 32-byte seed and then you expand to DZ and then you expand to private key, then you can't even mismatch between D and Z, and that's like even better. But we're getting more and more into academic attacks that are less and less practical. So like, security goes up, how much it goes up, debatable, but it certainly doesn't go down. So like seeds, we like them a lot. Click, Sophia, please. Yeah, so that says what I just said. Yeah, 32 bytes, yeah, right. So seeds are all upsides. So then the next question is, if they're all upsides and we like them, are they FIPS allowed? Ooh, this is a slightly old version of my deck, that's okay. Are they FIPS allowed? And the answer is yes, yes-ish, or the more updated version of my slides say yes, but confusingly. Like definitely yes, but also definitely it's confusing. So next slide. Oh, there's the next version of my slide. Cool. Yeah, so yes, but confusing. And then this last part, like if you store a 32-byte and then you expand, academically, this is true that it's better. in practice, do we care enough to do this? Not really. It's not worth the hassle. There is definitely a hassle here. I'll explain in a few slides what the hassle is, and we think it's not worth the hassle. So MLDSA seeds, for all intents and purposes, are 32 bytes. MLChem seeds are 64 bytes. We're going to sort of a bit pretend to ignore that. You can start with 32 and expand. Okay, next, please. So why is this confusing? It's because there's a few different sentences. Like if FIPS 203 had only attempted to address seeds in one sentence in one place, this would have been clear, but they don't. They try to address seeds in a few different sentences in a few different places that don't perfectly line up with each other. And then depending on which section you read first, you get confused about what you're being told to do. So this is FIPS 203 section 6. Section 6 is the internal functions section. And so we get this first sentence that says the key generation internal function in this section may also be used to re-expand the private key from a seed. Great. But then you read the next sentence and it says the keygen internal interface specified in the section should not be made available to applications other than for testing purposes. And you're like, what? How do I store a seed and then use it if it's only for testing purposes? This is very confusing. So you might read this and think that like a crypto module is allowed to store a seed internally, but not allowed to accept a seed from a file might be a valid way to interpret this. I could certainly see a hardware developer reading this and taking that interpretation. But wait, there's more. So it says up there, see section 3.3. So let's go take a magic tour bus trip to section 3.3. Sophia, please. Section 3.3 deals with destruction of intermediate values, and it says the seed generated in steps 1 and 2 of MLChem keygen can be stored for later expansion using MLChem keygen internal. As this seed can be used to compute the decapsulation key, it is sensitive data and shall be treated with the same safeguards as a decapsulation key. Yes. A private key is a private key. I should treat it like a private key, whether it's a big private key or a small private key. This sounds right. But this gives us clarity, right? This is telling us like the seed is a private key. You can treat it like a private key. Like this seems like it's a strict wording, but to me, this is actually a sort of a weakening. It says it's a private key. Treat it like a private key. Treat it like a private key and do whatever you do with private keys. Okay, yeah, great, cool. I like that. I think I highlighted a few parts of this. Sophia? Yeah. So this, I mean, can be stored. So this is this sort of means that anywhere you store a private key, you can store an expanded or you can store a seed. I think we can interpret this to mean if you want to carry keys in P12 files imported from a database or whatever, like I think this wording is telling us that's okay. How does this line up with that sentence that keygen internal should not be made available to applications? That's the part that I can understand why people are confused, but I mean, I think the intention is clear in the end. Next, click once. I think, yeah. So the click once is like this thing, CSP 800-227. And if you go look at reference 1, there's no reference 1. Reference 1 is says this will be published later. Go check this website again, which is like, oh, great, there's details in 227. And then you go to look it up and you're like, oh, I don't get to see the details yet. That's not as helpful as I wanted. Next, please. So yeah, this 227 thing, which I think will be all important in resolving ambiguities, NIST has, just want to advertise, NIST has scheduled a virtual workshop on 227, which is on February 24th, 2025. Sort of cool, the reference says it's 2024 and we'll get to look at it for the first time in 2025. We're all waiting with great anticipation to see what's going to be in this thing. Next. Oh wait, there's more. So that was FIPS 203, that was MLChem. If we swap over to the signature, MLDSA FIPS 204, it has a similar but not identical sentence. So this is back to section 6, this is the definition of the internal functions. It has that same sentence that says the interface of a key generation and signature generation specified section should not be made available to applications. Notice nowhere does it have that sentence saying you can store seeds and expand them later. That sentence is like just missing. So now we have like a prohibition on exposing to applications, but we don't have the preamble that says, but seeds are okay. So this is just like further confusing. Next slide. But it's sort of okay because that more technical section above contains the identical thing as the seed can be used to compute the private key. It's sensitive data, treat it like a private key. It's So I think in the end, after all of this very confusing Alice in Wonderland adventure through these somewhat contradicting sounding sentences, I think in the end we've decided this is actually fine. Like, it's poorly worded for sure, it's confusing for sure. Definitely some cryptographic module developers are going to get themselves confused for sure. But I think in the end we've decided the wording is, we know what NIST meant. NIST meant seeds are allowed. So I think this one we're just going to chalk it up to the wording's not great, but we know what it is. Let's just move on with our lives. Okay, so that's issue number one. I don't see anyone running to the line. I don't really want to prompt anyone running to the line because, as Paul said, we have a time
Let's do
constraint,
stuff
so-
at the end.
Okay, so
or
then-
on the list if we're out of time.
So next section then, please. Topic number 2. So if seeds are allowed, that's great. We're done. No, we're not done. We have to talk about types of seeds, direct seeds versus derived seeds. Next slide, please. So what I mean here is you get your seed out of a random number generator, out of a FIPS approved DRBG. And on this seed's magical journey from the DRBG to the keygen, you're allowed to like take a nap in a file and then like wake up and keep deriving, but you're not allowed to like do math in the middle. And it turns out that we actually kind of really want to be able to do math in the middle. So like, here's a code sketch of like a sort of totally reasonable thing we might want to do. So I'd said before, there's some, cool, good reasons that you might want to only store 32 and then expand it up to 64 and then feed it in. Size reasons, binding reasons. So this looks sort of reasonable. The scheme only claims 256 up to 256 bits of entropy. So like, yeah, this should be okay. However, click please. Not allowed. And it's explicitly not allowed in 203, 204. NIST has published on the mailing list that, that thing I highlighted in yellow, using only a 32-byte seed for MLChem is not allowed by FIPS 203, and we have no plans to allow it. I truncated off, but this is like signed Goran on behalf of the NIST PQC team. Like, this is like a very official thing. But then if you read later in the thread, they've backtracked this and said, well, okay, maybe it's a good idea, we'll consider it. So, all right, what does we're considering it mean? We'll get to do it in 2027? Okay, anyway, the point is absolutely unambiguously today, this is not allowed. So let's proceed with that. Clearly today, this is not. So what does it mean for this not to be allowed? You can't store 32-byte seeds for MLChem. Like, clearly, if you care about your thing being FIPS, definitely unambiguously not allowed. Okay, next, please. Yeah, this, and when in this follow-up statement that said we are considering it, they point out that this will require a republication of SP 800-133. So even if we get it, like, we're not going to get it soon. And I know IETF with this post-quantum stuff, like, we're well into the harvest now, decrypt later period. So like, soon matters. Next, please. Okay, so yeah, so this expansion to 64 and then is of course sort of useful thing, but like maybe not that useful. Are there other things that are definitely useful that we definitely can't do? So what else can we explore that is definitely not allowed? Next, please. X-Wing. The X-Wing hybrid makes this wonderful assumption, or wonderful observation, sorry, credit to Deirdre and Boss, that if you have an MLChem and an X25519, both of those things claim up to 256 bits of entropy, sort of in parallel. So if I just start with a single 256-bit seed, why can't I use that to seed both halves? It's a hybrid, you're sort of seems okay. So can I expand it up to 96 bytes and then split off what I need for the two algorithms? And this is, again, really clever and really efficient and has really nice binding properties. Next, please. No, not. Wrong, can't do that. So X-Wing has this beautiful combined simultaneous keygen, which is like definitely not allowed. Next, please.
Actually, before you go on, describe what you mean by not allowed, and you say FIPS. You actually mean
203.
FIPS. Well, this is not allowed by FIPS 203. This is not allowed by the CMVP.
I don't actually know the answer. I believe it's 203, but maybe someone knows the answer. My understanding is that 203 says that the input to the keygen must be direct output of the DRBG.
Okay.
Which
I wanted
PDF
because
is
you
definitely
earlier
not.
had started talking about FIPS, meaning FIPS validation.
No.
Okay,
I always, for this presentation, when I say FIPS, I mean 203.
thank you.
The wording of the PDF that is FIPS 203,
Excellent, thank you.
unless someone wants to correct me on that point. Okay, next, please. Okay, here's another thing you can't do. MLS. We like MLS. MLS is our better version of some other thing from somewhere else. We like MLS. MLS has this ratchet tree thing. This ratchet tree thing is really big and really complicated, and it ratchets forward every step. And if you take a big step back and you say, at some point I got some entropy out of a random DRBG, out of a hardware random number generator, and at some point later I derived an MLChem seed, and in between those 2 points the entire MLS ratchet tree happened. Like, the entire MLS ratchet tree is definitely a KDF that's not nothing. So this MLS is like basically on MLS on MLChem is absolutely not going to be FIPS allowed. Click please. So like, that's definitely clearly the thing that you're not allowed to do. I don't know to what extent anyone cares about a FIPS certified implementation of MLS, but if you do, you probably want to figure this out. Britta has asked that I cross-post this, or I start a post on the MLS mailing list pointing this out. I am an extreme tourist in MLS. I don't feel like I have the knowledge and depth or authority to really I can skim through for calls to keygen easily enough, but I don't really understand the implications. So happy to do that, but I don't know if someone like Britta or someone like Richard would be happy to help me write that posting to the MLS mailing list to make sure I get the details right.
Make Rowan do it.
All right, next. Topic number 3, private keys HSMs P11 and P12. IETF owns P12. IETF does not own the other things. Okay, next. So here's my horror scenario, which I presented at LAMPS, and I think in the course of LAMPS yesterday, we realized this horror scenario isn't maybe quite as horrific as I thought, but it's still my horror scenario. So let's combine a couple of facts here. Fact number 1, if you implement MLChem or MLDSA in cryptographic hardware, if you're the hardware developer, your boss is probably going to hand you the FIPS 203 PDF and say, here, go make this. You may not be a PKI guy or a COSE guy, or like you may not be aware of these like protocols. You're just implementing a simple API. Maybe you've read P11 spec, maybe you haven't. Maybe you've just given FIPS 203. And if that's all you're working off, you are likely to fall into these traps that we mentioned above, that like it definitely sounds like they don't want you storing the seed, and it definitely sounds like they don't want you exposing the internal keygen externally. So you're likely to not expose this API that we need to do all these things that we want to do. So we're going to end up with hardware and software products that don't give us the keygen internal to play with. Fact number 2, if your hardware module did not store the seed at keygen time, you don't get it back. It is gone. This is a one-way function. Seeds to fulls is a cryptographic one-way function. If you threw it away, it's gone. Fact number 3, some keys have extremely high values. Some keys protect millions or more dollars of assets, and they need to live for 30 years. And if we lose them, things are on fire. And if our hardware hits its end of lifetime and starts failing because it is physically rusty, we need to get the keys off of them onto new hardware. Fact number 4, IETF working groups are leaning towards seed-only private key formats. So if you do 1 + 2 + 3 + 4, there are going to be things that don't store the seed that in 10 years we need to get private keys off, and we no longer have a standardized format for doing so because they didn't store the seed, but we're only giving formats that accept seeds, and you can't go backwards, and this sounds like it's going to be a bit of a mess. So Obi-Wan Kenobi, you're my only hope, is can the IETF people who are specifying protocols that only want seeds, please talk to the hardware people who are building the APIs that are likely to throw away the seeds that we need. Can we get that conversation to happen now, please? Next slide. So in particular, I think OASIS PKCS 11 TC is probably the correct place to have this discussion. So I don't know if any of you lovely people are OASIS people. I'd love to have an IETF meets OASIS discussion on this private key seeds format thing. I guess reluctantly I'm willing to run this or spearhead this or kick this or something. So I did start a thing on the NIST PQC forum mailing list last week and starting to collect interested parties. if you're an interested party, please let me collect you.
You said you're speaking in April at the hardware module, folks?
ICMC. I
Yes.
don't know if I'm talking, well, I mean,
No.
talks haven't been accepted yet, so I can
Okay.
neither confirm or deny. But
Well, you might go
ICMC
there
is in
anyways
April.
and grab people by the collar and say this is important.
ICMC in April might be a great place, but also if we can do that sooner
Yeah,
is better.
yeah.
Yeah. Okay, next. Also the other great avenue that we have, big thanks to NIST, is NIST has this NCCOE PQ migration project that they run, which is, I think it gets all the PKI people and all the HSM people in the same Wednesday meetings facilitated by NIST. So I may try to bring this up at a NIST meeting. PHB, do you want to torpedo me now or do you want to torpedo me later?
Later would be preferable since we're time bound.
Later it is. Okay, topic number 4, hybrid chem combiner. Do you put the elliptic curve first or do you put the ML chem first? This is such a stupid thing. Why is it worth a slide? Next slide, please. So one of, not the only, but one of the large drivers of hybrids is certification. I'm trying not to swear, certification requirements. We all know the queue for FIP certification is years long. And one of the ways around that is hybrids. If you have a FIP certified RSA or elliptic curve like code base that's already certified and you get a hybrid that uses that code base in a completely black box way, doesn't meddle with it at all, well, then you still have a FIP certified elliptic curve or RSA. It just happens to be used in a higher thing, but like you haven't broken it, so it's still FIP certified, right? That's sort of one of the primary drive cases of hybrids. So the question then is, you know, how do we make sure we don't break that? So is that actually true? Can we actually get through a FIP certification that way? Another use case might be you want to deploy, you have a FIP certified ML Chem module and you want to deploy it with a non-FIP certified X20519. Or eventually, looking 5-10 years down the road, I mean, eventually NIST is going to remove RSA and elliptic curve from the FRIPS approved list. You don't want to have to rip all your hybrids out of production. If you deployed a hybrid, you want to just leave it deployed. Like if the hybrid gets its FIPS status removed, that also completely defeats the purpose of having done this in the first place. So these 3 points are sort of interesting because they all require FIPS in a slightly different way. In some of these scenarios, it's the traditional part that we're claiming FIPS for. In some of these scenarios, it's the ML Chem part that we're claiming FIPS for. And in some of these scenarios, we want to do one and then the other on the same key. Like I want to deploy a key today and claim that it is FIPS this way. And then I want to leave that key in production and in 10 years claim that it's FIPS the other way. So like if we have to physically change the implementation when we change which side we're claiming FIPS for, that's like, why have we done this in the first place? Next slide, please. So take a very quick but sort of deepish look here at the way you get away with hybrids. This is this is what we're basing chem combiners on. This is the FIPS 856CR2, line 6.2. This is the line in that document that I care about. This is how we get our hybrids through FIPS. Says that you're allowed to hash this counter thing with Z, which is your FIPS approved shared secret, with fixed info, which is like some other data that goes on the end. It is sort of out of scope for FIPS certification. And it specifically calls out that this recommendation permits the use of a hybrid shared secret of the form Z prime equals Z concat T, where Z is the thing you're claiming FIPS approval for, and T is like something else. So conceptually, you just sort of say, well, T is the beginning of my fixed info thing, and NIST FIPS doesn't really look at the FIPS info very closely, so T just sort of goes inside the thing you're not looking at very closely. Not quite, that's conceptually true. Technically, there's this auxiliary shared secret thing. If you're talking to a lab, don't just say it's fixed info, but like conceptually it's fixed info. Okay, so that's okay. Like this is okay. It sort of lets us do what we want. Next slide, please. The problem now is order. Because if I start off saying, I want my elliptic curve to be the thing that I'm claiming FIPS for, then it clearly has to come first. And if later it's the ML Chem that I want to claim FIPS for, well, then it has to come first. But that's a different deployment. That's regenerating my public keys. That's regenerating my certificates. Like, ugh. Cryptographically, these two things are the same. Like as long as your KDF is well behaved, and all the KDFs that we're proposing using here, either HKDF SHA-2 or anything from the SHA-3 family, they're all well behaved in the way we want. So cryptographically, these two things are equivalent. Also, I believe that as long as these two things are fixed length, it's also fine. And everything we're proposing doing in the IETF, it's all fixed length secrets. So like we really strongly believe that cryptographically there's no problem here. It's a FIPS certification issue problem. So next, please. So we've already had a phone call with NIST about this. We're making progress. NIST has acknowledged our desire. We're hoping that SB 800-227 resolves this, but since no one has seen 227 yet, we have no idea what we're going to get. Again, timing is an issue. If we're not going to get 227 like official so that I can take it to my lab until 2 years from now, that may be too late. So this is a bit of a sticky point. Next, please. Okay, last topic. This one was ludicrously fun at LAMPS yesterday.
For some value of fun.
For some value of watching Sophie write e-print papers live at the microphone. Okay, next slide, please. So I'm going to pose this as a game show question. If I ask you, if I hand you FIPS 204 and I say, how many APIs does FIPS 204 define? If you're writing a crypto library and you're writing a header file, a .h file, how many APIs do you have to expose to fully implement this spec? And if you say 2, you are wrong. It has algorithm 2, which is MLDSA sign, and it has algorithm 4, which is hash MLDSA sign, and that's 2. But wait. Next slide, please, or next, yeah, click. There is a third mode whose existence is implied by a comment on line 6 of algorithm 7. This thing does not have a name. This thing does not have an algorithm number. This thing does not list an API. Its existence is ephemeral, and that third thing is actually the thing we want. That third thing is what algorithm 4 should have been. And I have thoughts about how this review process went that I'm not going to say very explicitly, but you can imagine what I might say there. So, all right, next slide, please. So yeah, this doesn't have a name. Its existence is implied. Like its existence is implied. It's there. It's FIPS allowed. We're allowed to do it, and that's at least great. But it doesn't have a name, so I can't talk about it. I can't write an RFC that says do this because I can't point at it. So let's call this real hash MLDSA. And if we were to sketch out what the API for real hash MLDSA looks like, it's that. It's algorithm 2A, which takes, instead of M, it takes mu to indicate that this has already been pre-hashed externally. Don't pre-hash it again. And then you also need an alternate version of 7. You need 7A, which takes mu instead of M. And then you need to write a different software for algorithm 7 that just doesn't have step 6 in it. So it's a different compiled binary. So there are, in fact, 3 C APIs that are 3 different pieces of software in order to implement 204 properly. The thing that saves us here is they are mathematically equivalent. This thing that we're calling MLDSA and this thing that we're calling real hash MLDSA are mathematically equivalent. They take the same input, they produce the same output. So we can use the same OID for both. It doesn't need a second OID. You can use the same verify function for both. So like it's good, it's FIPS allowed, it doesn't need more algorithm registries, but like I can't really go to my hardware vendor and say, please implement this thing because it doesn't have a name, I can't talk about it. Next, please. Yeah, this is yeah, this basically says IETF is sort of choosing to just ignore that section 5.4 exists. Basically, this is a long slide that says we think section 5.4 shouldn't exist, and we think this thing called real hash MLDSA is what should have been in section 5.4, so we're just going to pretend that that's what FIPS 204 said. The problem is we can do that in the IETF, but we're going to need to interact with things that aren't IETF that maybe didn't interpret 204 that way, and that's going to be sticky. Next, please. So that brings me to the end, and I can give Paul back his 20 minutes. So there are 5 things.
20 minutes for the whole thing, so we have 10 minutes for Q&A.
Yeah. So In summary here, I brought up 5 issues. The first one basically gets a smiley face. Like the first one, seeds versus expandeds, whether that's actually allowed in the FIP specs and whether it actually encourages you to do something or not do something else. Like it's confusing for sure, but in the end, the thing we want to do is definitely allowed. So in the end, we'll give that a smiley face. Direct seed versus derived seed. We IETF definitely want to do derived seed things. We have, like, I think pretty good reasons that are pretty cryptographically sound to want to do derived seed things. And today that is absolutely unambiguously not allowed. So that we get to cry all the way until NIST gives us an SP that allows it, which is going to be not tomorrow. That gets a cryy face. Item 3, interaction with PKCS 12 files versus PKCS 11 HSM APIs, which is owned by Oasis, gets like a upside down smiley face because like it's sort of fine, we can get away with it, but like I think everyone needs, if we're going to do seeds, like everyone needs to do seeds, not just like IETF everyone, but like everyone, like TPMs and like everyone needs to do seeds. I don't know how we chaperone the world to all do seeds and no one do expanded, but I think we can probably figure that out. So upside down smiley face. Issue number 4, the order thing, again, really annoying. Again, we need to cry all the way to getting SP 800-227 like actually published so I can like take it to my lab and like certify a thing, so that like I'm a bit crying. And then the last one is upside down smiley face again, because this real hash MLDSA that is allowed, so that's good, but it's not obvious because it doesn't have a name, so I can't write an RFC that points to a thing that doesn't have a name. But writing down algorithms and giving them names is literally what the IETF does. So we can probably solve this problem.
But we're not going to call it real. Good. So we have, let's say, 8 minutes for mic line. Quinn, you are first. And you would have been first regardless because you're NIST.
I think Rohan was also in queue.
No,
Not anymore.
no, not anymore. So Phil, you'll be next, but Quinn's first.
Thank you, Paul. I'm Quinn Dang at NIST. Thank you, Mike, for giving a very nice summary of the things that are important for the IETF to work on. And as you said, the direct seed and the derived seed, we have been talking about it internally very intensively. Right now, we don't have an official answer for that yet. The second thing is the ordering. We knew that a long time ago, and that there are many other possibilities regarding to this as well. And we've been talking about that very intensively as well. And hopefully we'll be able to have an answer for that very shortly. Regarding to the many possible APIs, we realized that when we wrote the FIPS 203 and 204, and even 205, there are some options we had in those FIPS for many different reasons, performance reason and other things. And there are users who prefer one way over the others, but there are demand for all of those APIs. Depends on what environment you're looking for and how you want the system to behave. So that's why we got it. Yeah. So if you want the performance by computing the mu outside, it's good for a system, then you do it. And if you don't care about it, then you just use the one specified in the FIPS. But any options we provide in the FIPS, they are NIST approved. And then again, that was a good suggestion at the IETF in the working groups. We could write an RFC and specify the API and the algorithms, how to do the signing and verification with some modification of the code, and then that would serve our job very well.
Quinn, quick question. So 227 is going to be discussed publicly soon?
Yes, I think we plan to have a draft posted before the seminar, one day seminar in February. So we want to be able to have to review it, and then we want to hear about it.
Very good. Thank you.
Yeah, we're not like go here and then see the, no.
Right. Okay, very good. Thank you.
All right, thank you for the question.
And Phil, I'm going to make you next, even though you're after in the queue.
Yeah.
And let's keep this total under 5 minutes. Yeah. And we have plenty of mailing list time.
I was just going to say on the Oasis thing, their group did meet yesterday, and they are discussing exactly the seed issue. And also something that we need to raise with them that Russ Housley pointed out is on the signatures, there's a context string, which we would very much like to use and can't do it with PKCS 11 stuff because there's no slot to specify it. I think it would be good if we had some joint virtual with the Oasis people, which shouldn't be too hard to set up since they meet every N weeks anyway. So, you know, I've never done I've done a lot of stuff in Oasis. I've never done a liaison. I can't see how it could exist in their system though, because there is no kind of like Oasis architecture group. You want to talk to the TC direct?
I think I might just want to talk to some individuals, maybe even.
Okay, we're tight on time. Deirdre.
Yep.
There you are.
Agree on.
Believe me, it looks totally weird. I almost looked up there. That's right.
Agree on the keys. If NIST actually does clarify in either 227 or one of those other SB documents about generating a seed and then putting it through a KDF to provide the seed to MOCAM, that would be great, because if that's allowed, we may get a accidentally FIPS compliant X-Wing, which would be really nice. We wouldn't have to change a thing.
It wouldn't be the first time.
It would be lovely. And I'll say that like not having a 32-byte seed for MLChem and only having the 64-byte seed is not the end of the world. It would be lovely for a bunch of reasons, but using the 64-byte seed form for MLChem is almost as good as you can get in the known security analysis of the chems and stuff like that. There's other reasons. One may include extra stuff in your protocol KDF beyond the shared secret, even if you have those properties like the public key and the ciphertext. There's other non-game based security reasons you may do that, but it's not because of the sort of seed stuff. And then, yeah, for the order of things in the KDF, it is unfortunate that people are trying to shove SecP56 first so that they can get FIPS compatible hybrid key agreement now, because that will likely be not FIPS compliant further down the road. If you put MOChem first, left to right, you're probably going to be FIPS compliant for a long, long time. You're just not FIPS compliant today unless you have an MOChem validated module, which few people do today in November 2024. So if you want your hybrid to be around for a long time, you probably want to put the MLChem shared secret first. On the other hand, I am of the strong opinion that hybrids should be temporary. They may be around for a while, but they should be temporary. And if you are in a position to rotate your keys and protocols in a shorter time frame than some others, consider what going to a fully PQ solution would look like eventually, like we're implementing in a couple of places, including TLS, HBKE, and a couple other places. Thanks.
Thank you. Sean, you have the last word
Yep.
for this, and then we'll take this obviously not only to PQUIP mailing list, but also the NIST PQC mailing list.
All right, one serious and one haha.
Okay.
For the interaction with Oasis, don't try to do a virtual meeting or whatever. Just find out who's the rapporteur of the TC, send them an email with a list, the links of all of the drafts. So we're using seed and be like, so how do we get this fixed? Somebody in this group must have an employee that also goes there. It might just be a different person down the hall. Let's just call them and get it done. Right? Like, it doesn't have to take forever. And the funny haha thing is like, really, we got to pick a better name than real hash. I mean, it's kind of right there. You know, it's like open season.
Right. You don't get to call any protocols in the IETF secure, real, final, future. Yeah, don't do that. So great. Thank you very much. And thank you for all the people who Mike has been bothering all week for reviews, because he sent, this is like the 4th or 5th version of the draft, and they kept getting longer. So that's a good sign. So thanks very much. Okay, so Sophia, back to the chair slides, and go to the very end. And by the way, thank you, Sophia. I don't even know what time zone you're in, but greatly appreciated.
No problem.
Yes. Okay, so we have a few minutes to talk about something that came up on the list, which was where does the idea of algorithm commonality get discussed in the IETF, and what does it mean and such like that. And I just want to be super clear here. PQUIP does not get to pick or rank strength among the algorithms. That's for the CFRG. Now, and when I say pick, I mean pick for even for availability. The working groups are the ones currently and probably going forwards that will pick which algorithms and which modes and such like that they are going to be using in their RFCs. So there has been some discussion of the role of PQUIP versus role of SAG. And now let's have some words from RAD.
I'll just pick this microphone because there's less echo here.
Yeah. Oh yeah. 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 You know, this is like really freaky up here.
So as the people who were actually at CFRG and are now here realized that there is quite some overlap, including in presentations, right? So from the start, the PQUIP working group has been a little challenging to set up, whether is it properly limited in scope? Is this the right thing to do? And when this working group was created, the charter actually was given a extra check that said, like, in 2 years, let's review where we are and see if PQUIP is still needed as a working group in the IETF. So I think that sort of relates to this. Like, we are looking now at how we're handling algorithms and new ciphers in the IETF in general. We're discussing this at SAC again tomorrow. That's all still in the somewhat early stages, but I think the work in general happens there, and post-quantum algorithms are really only a subset of algorithms in general where we talk about SAC. So I think that discussion mostly happens at SAC. So that's on the algorithm part. Did you want to talk about the chartering now?
We might as well, and I'm not seeing a mic line yet. And again, I think the question of where are things discussed is better done on a list than instead of in a mic, especially given, like you say, it's going to be discussed tomorrow in SOG. And I mean, I know some people are flying away, but for those of us who aren't, I think that's the more appropriate venue. So, Mr. AD, tell us about our charter.
Yes, and just one more on the last bit. I did send out a 0.0 draft on Monday. It's a very short document because it tries to not set any new things, but just document what we already do. So please read that before the SAC meeting if you can.
Yep.
As for the charter, we really have to figure out what has been done and what would still need to be done. And that's a little bit tricky too, because like some of these, the sort of hand-holding older working groups documents are now proceeding towards the IESG, and that part of the work of the charter is getting done, right? One other element of the charter was PQUIP being the working group of last resort for working for protocols where the working group was already closed and there was no home to discuss this and work on this. And
SSH.
and it's a little bit conflicting with the we don't do actual work on drafts here, but that was also in the charter. So there was a bit of weasel wording in the charter, and as you say, it was mostly meant to cover SSH because at the time there was no SSH working group and absolutely no talking to the SSH community at large to even start one. So with SSH now being a working group and sadly meeting at the exact same time as we are right now, that clause might not be needed anymore. So even if we did recharter, which the clause said we should do in January when the review for this is up. So we need to recharter in January, or like, I guess it's a bit vague on whether you should be finished or start recharting, but let's just assume start. Then that part of the charter would go away. If then the part of clarifying and hand-holding people with terminology and advice has been completed, then I would really need to know like what is still left in this group to discuss that is not like largely overlapping with CFRG. And so that discussion has to happen on the list in the working group. And then hopefully you will all convince me to either open or close the working group with a broad consensus.
So you would like us to start the charter discussion in January as compared to now, especially because you still have a couple more documents coming your way soon from
Yeah,
us.
yeah, do those first. Like, let's not do everything at once. Yeah. So I'm not going to hold you on the January 25 or whatever deadline it's there. Like, let's be reasonable. But we should start at that point. We should start having a charter discussion.
And you would like us to start the charter? You would like us to prepare the charter wording, the rechartering wording, or do you want to do that?
I'm not so much worried yet about the exact wording. I'm more talking about the actual sort of content in like what would we plan? What do we want to do? Like if you can't come up with things you want to do, then I don't really need weasel wording to say what you're going to do to remain open.
Okay, sounds good. So we still have about 5 minutes left. I propose that what we do in the next month is finish our documents, including the one that was supposed to close today, but we've got a few more days. There's going to be more discussion on the terminology on the PQC for engineers. We will figure out about the hybrid terminology document, get that unstuck from you. And again, sorry I used the word stuck, but we unjammed, and spend December on that. And then our work here in January is should we continue? Do we want to continue? Do we have work to continue? Or are we one of the few working groups that has the opportunity to recharter and say, nope, not needed? So we'll start working on that in January.
And also, just a completely random other side note, please don't end working group last calls in IETF week. Just please add a week next time.
Yeah. When I did that, I looked at the date and I thought it would be cute. And then after I did, I was like, no, that wasn't very cute. So, yeah. Okay, well, we're basically at time. So thank you very much. We've got a couple of things. Wait, John has jumped in the queue. Oh, and Joe Harvey. Joe, be quick. And then John.
Okay. I just had kind of an observation from this week that there's some groups that are working on things like LAMPS, Jose, IPsec, where the drafts cross-reference each other, but they're not necessarily consistent because they're just referencing. So other things may have same concerns. How do you think PQUIP might fit with those PQ constructions to help bring that together so there's consistency instead of just cross-referencing to the kind of charter question discussion we just had a moment ago?
Okay, sounds good. We can look at that. And also, anybody can say on the PQUIP mailing list, I see working group A and working group B have cross links or whatever, and it's not clear to you. I mean, obviously bring it up in the working groups, but bring it up in PQUIP as well, because working group C is about to make the same mistake.
Hi, it's John Gray. Oh, very loud. Sorry, you cut off the mic line before. I just wanted to mention at ICMC, I asked the author, and I put it in the chat, of PKCS 11. So 3.2, they described the API. They are going to support the context. They're doing it through a parameter object. You can do parameters in PKCS 11, so you can add the context in there. So he said, I asked him on the mic line, he said, yes, we're supporting the context. So I just wanted to let everyone know they are planning to support it. Thanks.
Great, thank you. That's good news. So one smiley face might turn around. Okay, very good. Thanks very much. Please be active on the list. Please look at working group last calls, especially for our documents, and soon look at our rechartering. And again, thanks, Sophia, for running slides and all of that remotely. And don't applaud, Jesus. It's bad enough being up on a stage like this with lights.